So you're planning to get your hands on a modern compression ignition engine. Maybe you're prepping for that RETR12 unit. Well, hold on a second. Before you even think about picking up a wrench, we need to talk. Because what we're about to cover, it's not just some helpful background info. It is the absolute foundation you've got to have. Let's dive in. 2,500 bar. I'm going to let that number hang in the air for a moment. That's over 36,000 PSI. Think about that. This is the kind of pressure running inside some of the common rail diesel systems you're going to be working on. At that pressure, diesel fuel stops being just a liquid. It becomes a cutting tool, something that can literally blast right through your skin in an instant. And that, right there, is why we're here. Mastering this incredibly powerful and, potentially dangerous technology is all built on a few core principles. You get these principles right, you're well on your way to becoming a real diagnostic pro. But if you get them wrong, well, the consequences can be pretty severe. So let's start with the most important pillar of them all, safety. And this isn't just a friendly suggestion, it is the absolute #1 first step. Before you run a single diagnostic test, before you touch a single component, your safety procedures have to be locked in. Let's be crystal clear about the risk. We're not talking about a little cut or getting some fuel on your hands. A fuel injection injury is a full-blown surgical emergency. The fuel gets forced under your skin and it just starts killing tissue from the inside out. It can literally poison your entire system. And the scariest part, the entry wound is often so tiny you might not even notice it's there. So, how do we prevent something that catastrophic? Simple. We follow a non-negotiable protocol. First things first, engine off, key is completely out of the ignition. Then, you must follow the specific manufacturer's procedure for depressurizing the system. And here's the golden rule, the one you never ever break. You do not crack open a high-pressure line while that system is live. Wear your PPE, take off any jewelry. It's that simple and it's that crucial. All right, once we have safety completely dialed in, we can move on to pillar number 2. You've got to know the machine. You just can't diagnose a system you don't really understand. I mean, how can you? Effective diagnosis is basically impossible without a deep, working knowledge of how all the pieces of the puzzle fit together. And it all starts right here, with this fundamental difference. You see, a gasoline engine uses a spark plug to get things going. A diesel engine, it does something way more dramatic. It squeezes the air so hard that it gets incredibly hot, and then it injects the fuel, which just explodes on contact. This principle of compression ignition is why the fuel's cetane rating is so critical for a diesel to run right. Now, to make that happen, the fuel goes on a very specific journey. It starts out on the low-pressure side of things, from the tank, through a lift pump, and a filter. Then, boom, it hits the high-pressure pump. That's what sends it rocketing to the common rail and finally to the injectors. Knowing this path is so important because, get this, a problem way back in the low-pressure stage can easily disguise itself as a high-pressure fault. So who's running this whole show? Well, that would be the engine control module, the ECM. You can think of it as the engine's brain. And all these sensors, those are its senses. The ECM is constantly getting a flood of data from all these points, making millions of calculations every single second to decide the perfect timing and amount of fuel to inject. It's pretty incredible. Which brings us right to pillar number 3, the art of diagnosis. This is where you put on your detective hat. Your job is to take all the clues, the symptoms, the data from your scan tool, and use them to track down the single root cause of the problem. You're not just chasing symptoms, you're hunting for the real culprit. Here's a classic example. A customer comes in complaining about black smoke. Now, it's really easy to just jump to a conclusion, right? Oh, must be a bad injector. But what if it's something way simpler, like a clogged fuel filter that's starving the system and causing the ECM to dump in too much fuel to compensate? See? One symptom can have a bunch of totally different root causes. And this leads us to a super important point about diagnostics. Scan tools don't give you answers. They give you data, and it's up to you to interpret it correctly. A low rail pressure fault code is the perfect example. That code could mean your high pressure pump is failing, or it could just mean you have a $10 clogged fuel filter on the low pressure side. The electronic symptom, it's exactly the same. So what's the secret? It's having a structured strategy. Yeah, you start with the scan tool data, but that's just step 1. From there, you have to systematically perform low-pressure tests, then high-pressure tests, and electrical checks to roll things out one by one. This logical process is what separates the pros from the people who are just guessing.
And that brings us to our final pillar, the professional fix. You've done the detective work, you found the faulty part, and you've replaced it. Awesome. But you're not done. In fact, one of the most important steps is just about to begin.
You know, our source material has this quote that just nails it. It says that calibration and recalibration is one of the most commonly skipped steps in diesel repair, and skipping it means the repair is not complete. Think about that. You can do everything else right, but if you skip this, the job isn't actually finished. So a true professional repair always has these 3 stages. First, you repair the part. Second, you calibrate it. You have to actually code the new component to the ECM so the brain knows how to talk to it. And third, you test your work. Clear the codes, run the engine, check performance, and make sure everything is working perfectly. You got to do all 3.
And that's really what it all comes down to. Safety first. Know the machine inside and out. Diagnose like a detective, and always complete the entire repair process. These aren't just steps on a checklist. They are the core principles that separate someone who just swaps parts from a true master diagnostic technician.
So, I'll leave you with a question to think about next time you wrap up a job. The fault is fixed, the new part is bolted in. But is the job really done?